Hey squad, and welcome back to my YouTube channel. I am Yuri Tochilo, and let's get started. Today we will break down the theory of constraints, starting with what it is, moving through the 5 focusing steps, examining the critical chain method, and reviewing buffer types. The theory of constraints is based on a simple idea. Every system has at least one constraint that limits its performance. In project management, a constraint is our bottleneck, the weakest link that determines how fast the entire project moves. It can be a resource, for example, one overloaded engineer, a process, like slow approvals, or even a policy, such as rigid governance. TOC shifts our focus. Instead of trying to optimize everything, focus on the one constraint that actually controls the outcome. TOC provides a practical framework called the 5 focusing steps. Let's walk through them using a project example. A company is deploying new network equipment across multiple customer sites. Network engineers complete configurations quickly, but every deployment is delayed because the security team must review and approve each change before implementation. Step 1. Identify the constraint. Determine what is slowing down the project the most. Example: network configurations are ready, but deployments are waiting for security approvals that take up to 2 weeks. Step 2. Exploit the constraint. Improve the efficiency of the constraint without adding resources. Example: security reviewers prioritize critical changes first and use standard approval templates to reduce review time. Step 3. Subordinate everything else. Adjust all other work to support the constraint. Example: engineers stop preparing more deployment packages than the security team can realistically review. Step 4. Elevate the constraint. Increase the capacity of the constraint. Example: the company assigns an additional security engineer and introduces automated compliance checks. Step 5. Repeat the process. Find the next bottleneck and focus on it. Example: after security approvals become faster, the team identifies that equipment procurement is now the primary constraint because hardware deliveries are taking too long. Traditional project management often tries to optimize everything, reduce cost, improve quality, speed up all activities. But TOC challenges this approach. Improving non-constraints does not improve the overall system. Example: if QA is our bottleneck, speeding up development only increases backlog, not delivery speed. TOC introduced the critical chain method, CCM, a more realistic alternative to the critical path. The key difference: CCM accounts for both task dependencies and resource constraints. Instead of protecting every task with extra time, CCM removes individual safety margins and consolidate them into strategic buffers. Let's review buffer types. First, project buffer, placed at the end of the critical chain, protects the final deadline and absorbs overall delays. Second, feeding buffers, placed where non-critical paths connect to the critical chain, prevent delays from secondary tasks impacting the main flow. Third, resource buffers, ensure critical resources are ready when needed. CCM changes execution behavior. Focus on finishing tasks early, not just on time. Minimize multitasking. Prioritize flow over local efficiency. Example: our project depends on one key architect. Traditional approach: tasks run in parallel. The architect is overloaded. Work slows down. CCM approach: tasks are sequenced based on resource availability. Buffers protect the schedule. The architect works without interruption. As a result, more predictable and faster delivery. Here are the practical takeaways. Identify the real bottleneck. Stop multitasking on constrained resources. Limit work in progress. Protect the constraint from interruptions. Continuously reassess as the constraint shifts. Alright, that's all for today. Don't miss out, hit like and subscribe. Stay awesome and as always, peace.